Hey everyone, welcome back for another deep dive with us.
Glad to be here.
Today we're looking at secondary school science.
Oh, very cool.
Yeah, and specifically how learning technologies and learning sciences are kind of coming together to try to make science education more equitable.
It's a really interesting area.
It is. So we are diving into a chapter today called 15 Synergies between Learning Technologies and Learning Sciences, Promoting Equitable Secondary School Teaching, by researchers Linn, Donnelly-Hermosillo, and Gerard.
All right.
And they really paint a picture in this chapter of how classrooms are kind of being transformed to be more inclusive and effective for all students.
Yeah, it's really moving away from that idea of a pipeline, which I think has been kind of a dominant metaphor in science education for so long.
Definitely.
You know, just getting kids ready for STEM careers.
Right.
When really it should be about empowering them to tackle real-world dilemmas.
Yes, exactly. And, you know, they even use these examples in the chapter like COVID-19 exposure and treatment. Or like weighing the pros and cons of gas-powered versus electric cars.
Things that we all need to be scientifically literate about.
Exactly. These are things that everyone faces in their lives.
Absolutely.
Not just people who are going to go on to be scientists or engineers.
Right.
So one of the things that really stood out to me in this chapter was this idea of authorable and customizable environments.
Oh, yeah. ACs.
Or ACEs.
Yeah.
And I think, you know, this is a really fascinating idea.
They're pretty revolutionary, I think.
Yeah.
You know, because it's all about having this platform where teachers can really personalize instruction for each student based on, you know, the evidence that they're seeing from the student's work.
Right. And it combines, you know, they talk about learning management systems, but also these pedagogical frameworks like knowledge integration.
Right. Well, and it brings those things together.
Yes.
So you have the technology piece, but you also have the, you know, the learning sciences piece.
Right.
All kind of interwoven.
So when we talk about knowledge integration, what does that really mean for somebody who maybe hasn't encountered that term before?
So knowledge integration really emphasizes helping students connect new information to what they already know. And build kind of this coherent understanding of a topic. So it's not just about memorizing isolated facts.
Right.
It's about building these webs of interconnected ideas.
So building a bigger picture.
Exactly. Yeah.
Instead of just these little tiny pieces.
Yeah, it's like, you know, putting together a puzzle.
Yeah.
Rather than just having a bunch of random pieces.
Right, exactly. And you know what's so interesting is they talk about in this chapter how some states and districts are starting to recognize ACs.
Wow.
And open educational resources as like legitimate curriculum options.
So it's not just a supplemental tool.
Right.
It's like becoming...
It's moving it to the core.
The core of the curriculum. That's a huge shift.
The chapter also talks about how technology can make these really complex scientific phenomena more visible and accessible to students.
Yeah. I mean, think about it. You can't really see buoyancy happening.
Right.
At a molecular level in a traditional classroom.
Yeah.
But with, you know, with simulations, you can actually visualize how those forces are working.
Right.
You can manipulate variables. You can test out different scenarios.
It's like giving students microscopic vision.
Oh, exactly.
So I think, you know, one of the examples they give is visualizing buoyancy with a mass by volume grid.
Yeah.
Which, you know, if you can see it, then you can really start to understand it.
Absolutely. And it makes it much more tangible.
Yeah.
And interactive.
Yeah.
Which I think is really important for a lot of learners.
Definitely. And speaking of engagement, the chapter also highlights how technology can really transform collaborative learning in science.
Yes. Collaboration is so crucial in science.
Yeah.
And I think what's exciting is that, you know, we're moving beyond just, you know, sticking kids in groups.
Right.
And hoping for the best.
Yeah, just because you're in a group doesn't mean you're collaborating.
Exactly. And so the chapter talks about, you know, computer-supported collaborative learning, or CSCL.
Right.
And the tools and platforms that are really designed to support that kind of productive collaboration.
Like the Wise Idea Manager that you mentioned earlier.
Exactly.
Yeah.
Yeah, knowledge repositories like that where students can really organize their ideas, share their thinking, build on each other's explanations.
And they even talk about how research has shown the value of divergent ideas.
Isn't that interesting?
Yes.
It is.
In those repositories, so students are actually recognizing the importance of ideas that challenge their own.
Yeah, they're actually valuing that.
Yeah. Even if they don't agree with them.
Yeah. Which I think is really, you know, kind of a key part of scientific thinking.
Absolutely.
Is being able to consider multiple perspectives.
Right, being open to other ideas.
Exactly.
So then the chapter kind of shifts gears and talks about personalized automated guidance, which I think is really fascinating.
This is where AI comes into play.
Yes. AI is stepping in to kind of help tailor support to students.
Right. And it's not about replacing teachers.
Right.
It's about giving them this incredible ally.
Yes. It's like having this virtual tutor who can give each student, personalized hints, feedback based on what they need.
Exactly. And it's not just about giving them the right answer.
Right.
It's about guiding them towards a deeper understanding.
Yeah. And they use the example of the WISE platform, which uses natural language processing, or NLP, to analyze student writing and offer that guidance.
That's pretty cool.
It is. But what's really interesting is that they found students who used an annotator tool, which models the process of revision, actually learned more than those who just received the automated guidance.
So they're not just getting the hints. They're actually seeing how to revise their thinking.
Exactly. And so it's not just about what they're learning, but how they're learning.
Right. It's about the process.
And becoming more self-directed learners.
Yeah.
Yeah. So I think that's a really important distinction.
It is.
But all of this, advanced technology, all this innovation, it really makes me wonder, what about the teachers?
Yeah. Where do they fit into all of this?
How are they being supported?
Right.
To kind of navigate this new world of, ACEs and virtual labs and AI-powered guidance systems?
It's a great question, and luckily the chapter digs into that in the next section.
Excellent. So stay tuned as we continue our deep dive and explore how technology is transforming the role of the teacher in science education.
One of the most exciting things that's happening, I think, in science education is this idea of making scientific phenomena visible and accessible to learners.
I remember even in science labs, I could see something, but it didn't really connect.
All right, you have to be able to manipulate it and test it out.
Yeah.
And so, the chapter talks about traditional labs, which, of course have value.
Right.
But they can be a little clunky, a little intimidating. And what virtual labs can do, and especially when they're embedded within these ACEs that we talked about, they can really streamline things and let students focus on the thinking part of science.
So it's not just watching something happen.
Right.
It's about actually interacting with it.
Right. It's about making predictions, testing variables, grappling with those results.
Yeah.
And they highlight some really cool examples in the chapter.
Okay.
They talk about VTT interactive simulations, which cover a vast array of science topics.
Wow.
Are designed to work on pretty much any device.
Okay.
And can be seamlessly integrated into ACEs.
It's like having a whole science lab in your pocket.
I love that analogy.
Yeah.
And, these virtual labs can often go beyond what's even possible in a physical lab.
Oh, interesting.
So, imagine you're trying to understand how molecules move during a chemical reaction.
Okay.
In real life, you can't see that happening.
It's too small, too fast.
Exactly. But in a simulation, you can see those interactions. You can zoom in and out. You can slow down time.
It's like giving them superpowers.
It really is, yeah.
Yeah.
And because these virtual labs can often collect and display data automatically, it frees up the students to really focus on analyzing and interpreting.
So they can actually think about it.
Exactly. And that's where the real learning magic happens.
Instead of just the procedure.
Right. And they can repeat experiments easily. They can test different ideas.
Without having to wait for equipment or clean up spills.
Exactly.
That's awesome.
It just makes it so much more accessible.
Yeah.
Which is a huge win, I think, for equity as well.
Yeah, definitely.
And then the chapter goes on to talk about the rise of computational thinking in science education.
Computational thinking.
Yeah. It's a bit of a buzzword.
It is. And sometimes I feel like I don't really know what it means.
Well, it's a fantastic skill set. You know, think about it as applying the logic and processes of computer science to solve problems.
Okay.
Even if you're not actually writing code.
So like breaking a problem down into steps? Yeah. Looking for patterns?
Exactly.
Testing solutions systematically?
Yeah, those kinds of things.
That makes sense.
And there are tools and activities now that allow students to apply these computational thinking skills to real-world science problems.
Okay.
That are relevant to their lives.
Interesting.
So, for instance, students might investigate the link between pollution and asthma rates in their community.
Okay.
Or they might design a model to test the effectiveness of green roofs in reducing urban heat.
So they're actually doing science.
Exactly. They're not just reading about it.
Yeah, I like that.
Yeah. And it really helps them, get invested in the process, connect science to their own experiences.
It's all starting to come together, I feel like.
It is.
This personalized learning, real-world problem-solving, computational thinking. It just feels like it's creating this much more engaging and empowering science education experience.
I agree. And then, they also talk about the use of physical and virtual artifacts in learning.
Artifacts? What do you mean?
So think about things like robotics, 3D printing.
Okay.
Even e-textiles, where you're, weaving circuits and sensors into fabric.
Oh, wow.
So students are designing, building, creating.
Right, hands-on.
Exactly. And it really taps into that kinesthetic learning style.
Yes.
And research shows that these kind of maker activities can be really powerful for students who maybe don't thrive in traditional classroom settings.
Right.
It gives them a tangible way to express their understanding of scientific principles.
Yeah.
And they're developing, important engineering and design skills along the way.
Absolutely.
And then speaking of different ways of learning, the chapter also highlights how technology can support collaboration in science education.
We touched on that a little bit earlier.
We did. And this is where I think things get really interesting.
Okay.
Because we know that collaboration is at the heart of how real science happens.
Yeah.
And technology can help us recreate that collaborative spirit in the classroom.
But you said earlier it's not just about putting kids in groups.
No, it's not just about that there are now tools and platforms specifically designed to support effective online collaboration in science.
Like those knowledge repositories.
Exactly, things like the Wise Idea Manager. But there's also been a lot of research into how to structure those online interactions to make them truly productive.
Because you can't just throw kids in a chat room and expect them to collaborate.
No, you can't. It's about providing structure and scaffolding, helping students learn how to effectively share their ideas, build on each other's thinking, give constructive feedback.
So teaching them the language of collaboration.
Exactly.
Yeah, that makes sense.
One area where I've seen a lot of innovation is in the use of peer critique tools.
Oh, yeah.
It's amazing how technology can facilitate that process. But again, it's not just about, saying good job or needs work.
Right.
It's about providing specific, actionable feedback. Based on, clear criteria.
Which takes practice.
It does, and that's where technology can step in.
Okay.
So some platforms, provide models or templates for giving effective feedback.
Okay.
And they even use AI to analyze that feedback and flag potential issues like bias or, lack of specificity.
It's like having a coach for peer critique.
Exactly.
Wow.
And, the research shows that this kind of structured, supported peer critique can lead to significant learning gains.
That's awesome.
For both the reviewer and the person receiving the feedback.
So everybody wins.
Everybody wins. It's a win-win.
I love how they emphasize the importance of diversity in these collaborative environments.
Yes, it's crucial because when students interact with peers from different backgrounds and with different perspectives, it helps break down those silos.
Yeah.
And it fosters a more nuanced and inclusive understanding of science.
So it's not just science content anymore.
Right. It's about those social skills, communication skills, critical thinking skills.
Yeah, it's about preparing them to be good citizens.
Exactly. Yeah. Engaged, informed citizens.
So, all of these innovations are incredible.
They are.
But it also makes me think about, what is the role of the teacher in this increasingly tech-driven learning environment?
It's a crucial question and one that the chapter addresses directly. Technology is not about replacing teachers.
Okay.
It's about giving them even more powerful tools and insights.
So they can do what they do best.
Exactly. To guide, support, and inspire their students.
So if technology is the sidekick, the teacher is still the superhero.
Exactly.
I like that.
And in the next part, we'll explore some of the specific ways technology is empowering teachers to create even more personalized and equitable learning experiences.
All right, so we've talked about how technology is really changing science education for students. Right. But what about the teachers?
Right. Where do they fit in?
How are they being supported to use all of this?
All this new stuff.
Yeah, all these new tools and technologies.
Yeah. Well, and the chapter really gets into that. It talks about how we're moving away from these traditional models of professional development.
Okay.
Where, researchers kind of hand down information to teachers.
Which isn't very collaborative.
Not really. No, it's a one-way street.
Yeah.
And so they highlight this rise of research practice partnerships, or RPPs.
Okay.
And in these partnerships, teachers aren't just passive recipients of information. they're actually collaborating.
Oh, that's cool.
With researchers to co-design and customize curriculum and teaching practices.
That makes a lot more sense because they're the ones in the classroom every day.
Right, they know their students best.
So they should be part of the process.
Exactly. And, RPPs really recognize that teachers bring so much expertise to the table.
Yeah.
And they often start with these research-based materials.
Okay.
But then guide teachers in how to adapt those materials to their specific context.
So it's not about starting from scratch every time.
Right. You don't have to reinvent the wheel. One thing that the chapter stresses is the importance of transparency.
What do you mean by that?
Well, making the pedagogical framework behind those materials clear and accessible to teachers.
So it's not just what they're teaching, but why they're teaching it that way.
Exactly. Understanding those underlying principles.
Okay. That makes sense.
And this is where technology can be really valuable.
Oh, how so?
Well, they talk about tools like the curriculum visualizer.
Okay.
Which allows teachers to see the structure and flow of a unit.
Okay. The
learning goals behind each activity.
Yeah.
And then make informed decisions about how to adapt it.
So they can really see how it all fits together.
Exactly. It's like a behind-the-scenes look at the curriculum design process.
Yeah, that's cool.
And then, of course, there are those teacher dashboards we've been talking about.
Yeah, the ones that can help teachers identify struggling students.
That's one piece of it, but they can do so much more.
Oh, really?
Yeah, dashboards can reveal patterns in student thinking.
Okay.
Highlight common misconceptions.
Interesting.
And even suggest, potential instructional adjustments.
So it's like having a co-pilot.
Right there with you in the classroom.
Helping you figure out what to do.
Yeah, helping you make sense of all that data.
That's amazing.
It's a pretty powerful partnership.
Yeah.
But as the chapter points out, these dashboards need to be designed in a way that's truly actionable.
Right, because it can't just be this overwhelming amount of information.
Exactly. It can't just be a data dump. It has to be clear, concise information that teachers can actually use.
To make decisions.
Yes, to make real-time decisions in the classroom.
In the moment.
Yeah, it's about transforming that data into insights that actually lead to better teaching and learning.
So they talk about this hybrid approach.
Yeah.
Where teachers use these dashboards both during professional development and then in the classroom.
Yeah, it's a great way to bridge that gap between theory and practice.
So they can see how it works in real life.
Exactly. They can, analyze student data together during professional development, refine their strategies, and then apply that knowledge in real time as they're teaching.
So it's a continuous cycle.
It is, yeah. Constantly learning and improving.
That's awesome.
For both teachers and students.
Well, this has been such a fascinating conversation.
It has.
About how technology and learning sciences are coming together to make science education more equitable.
Yeah.
So I guess as we wrap up our deep dive here, what would you say is the key takeaway message for our listeners?
I think the big takeaway is that technology, when it's thoughtfully and intentionally implemented, can be a game changer for science education.
Yeah.
We've seen how it can personalize learning, make science more accessible and engaging, and empower teachers, foster collaboration.
And it's really about moving away from that old pipeline mentality.
Right.
And making sure that science is relevant and engaging and empowering for all students.
Exactly, regardless of their background or their future aspirations.
Absolutely. Well, thank you so much for joining us on this deep dive.
It's been a pleasure.
Into the exciting world of technology and science education, we hope you learned something new and came away with some inspiration for the future of learning.
I hope so.
And for our listeners out there, what other possibilities can you imagine for using technology to personalize and enhance learning? What kind of future can we co-create if we keep pushing the boundaries of innovation and collaboration in education? It's something to think about. Until next time, keep exploring, keep asking questions, and keep diving deep.